In this video, we'll look at question 10 from the second paper of the 2017 exam. And in this question, we are supposed to say which of these five is a sufficient condition for the integral from 1 to 3 of f of x dx to be 0. And before we do anything else, there are two options which we can immediately exclude. Two options which, in fact, don't pose any restrictions on the integral itself. And that's all this business about the value of the function being something at a certain point. That doesn't tell us anything at all about the integral of that function around the point. That allows us to look at the three more serious options, which all have something to do with like a certain mirror image. Say option C is in fact describing something we call an odd function, one which might look something like this. It's symmetric around the origin, and when we take its integral on a symmetric interval, it will in fact be 0 in total, because this negative area here will cancel with a positive area from 0 to, say, a point A, and here is negative A then. Such a function is called odd. But that's no good for us, because our interval goes from 1 to 3, not from, say, negative 3 to 3. So this doesn't really apply. We need a function which is kind of odd around the point 2, which is in the middle of the interval from 1 to 3. In other words, it'd be really cool if we could just move this bit to the right to point 2, because then, as we see, the integral from 1 to 2 is exactly negative of the interval from 2 to 3, and the two cancel, and we get an integral of 0. And which of these two statements now expresses that in mathematical notation? That points which are the same distance from to either side of it have values negatives of each other. So say if at 4 the value is pi, then at 0, which is a distance 2 from 2 to the other side, to the left, not to the right, well, this time we want negative pi. So that's just an example. And based on that, can you decide which of these two is the correct one to pick? It is in fact option D, which quite literally tells us that at distance x to the right of 2, the value is negative of the value distance x to the left of 2. So that's exactly what we said, what we described before. And hence, without knowing anything else about the function other than it exists and that it's kind of odd around the point 2, we can still say that the integral from 1 to 3 will be 0. So D is our final answer to this question.